So with that, I'm delighted to introduce you to Zach Shapiro, who's the lead data engineer at Nextdoor. So can I have a show of hands in the room for those that are using the Nextdoor application today? Yeah, a fair few. So for those that don't know, Nextdoor is the best way to be connected to your local community. They have a phenomenal growth story with over 85% coverage across local neighborhoods in the US. And yeah, they've got some awesome big data use cases. So with that, I'm going to hand over to Zach and yeah, enjoy the last session.
All right, thanks a lot. What I'm going to talk about is so we're going to go over a little bit about just what is Nextdoor, what do we do, what data challenges were when I got there a couple 2.5 years ago, and then kind of what we did to flip things around and really build a foundation and a data platform on top of that, and then how that platform has been serving us, and what it's like now that we're live and running with everything. So Nextdoor is the private social network for your neighborhood. There's all kinds of ways to connect to people. You can clearly, we've got social networks for all kinds of things, but we think that really the neighborhood is kind of one of the original social networks before there was the internet. That's how you knew people around you. And all kinds of people in your neighborhood, your police department, fire department, they're on Nextdoor. Your neighbors, people use it for finding a plumber or getting a restaurant recommendation, all those kinds of things. And one of the reasons I put up these slides is for people who work at Nextdoor, we're very passionate about building that community and making the local community better and stronger. When our founders launched Nextdoor, there was no social network that revolved around a local area, right? And so this has really evolved into the best way to get information about what's going on, near where you live. So Nextdoor was built around the ideas of the fact that you've got a private community that's based on where you live. We verify every member to ensure that they actually live where they say they do. You've got to use your real name. There's some sense of trust between members that I know who you are, I know where you live. So if I'm giving away stuff, or if I'm selling something to you, I know who you are, and you know that I really do live in this house. So we do things like recommendations. It's one thing to ask, what's a good restaurant, but it's another thing when you've got all the people that live right where you do. The restaurant recommendations might get skewed towards things that are convenient and also good. So this is what our coverage looks like. We're in over this slide's probably 6 months old, so it's even bigger than this, but we cover pretty much all urban, suburban areas, and yeah, we're across the US, all 50 states. And over the last few years, we've seen quite a lot of growth, and our growth, I would say, is not quite as hockey stick as something that is a little bit more viral, because really, your neighborhood probably exists anyway, and there's nothing that is compelling you to join it. We do postcards as a way of kind of growing membership within your neighborhood, but it really starts with someone making a neighborhood and then inviting people around them to join it. So it is really driven by your neighbors that make that happen. So there's not a lot of global things that we can do that just because I have an account doesn't mean my dad who lives across the country, there's no benefit to him in his neighborhood that I have an account. He can't talk to me on Nextdoor. So our growth is kind of slow and steady, and that we've seen all kinds of growth. The number of users, number of employees we have in the company, we're up over 200 people now. The volume of data, as our users use things more, we instrument more things. So, and we've recently started expanding into the EU. We're in several countries there now. This, of course, has made GDPR a fun activity right now. So I'm not going to talk about anything about what we do about GDPR yet, because we're still in that process. So, of course, when I got there 2.5 years ago, I was all excited to join, and everything was, I was told, well, we've got this great architecture, and everything's really sophisticated, and we're, in really good shape. And I joined, and I kind of felt like this. I think there had been, we had tons of Tableau dashboards and tons of, we had everything built out in Redshift, and the data had grown and really no one had been doing anything with it. And so, whenever you have that kind of transition of, someone builds a bunch of stuff and then leaves, you wind up in this situation where, things are just not working. So, we're ingesting a lot of data. We had all of these, queries and dashboards running, but man, there was some old ETL system that nobody understood. We couldn't see what was going on. There was, monitoring and alerting was there, but we would get 100 alerts a day that meant nothing, and then, we'd lose data, and there would be no alert at all. Someone would just come back and say, "Oh, these numbers look weird. What's going on?" And then we had this awesome thing where, there was this time-based approach to dependencies. There was no explicit hey, I'm gonna, I need this data. It was like one thing ran at 5 and another thing ran at 6, and I'm sure once upon a time the thing that ran at 5 finished before 6. But by the time I got there, that wasn't the case. So, and there was no explicit, relationship between these things. And I think probably the biggest issue was the company had really lost trust in the numbers, right? I don't know if you guys have been in that situation, but it's rough. That was very rough to get out of, because we would build something, but anytime a number fluctuated, the first assumption was there was something wrong in the data, something wrong in the data pipeline. It was really hard to make a conclusion that, there's something wrong with the product, or something's going on. We need to understand that. So Redshift was absolutely full. It wasn't able to keep up. We were in these long commit queues. It would take 5 minutes to run a select count star on something. Oops, sorry. And we had and we continue to have 3 data engineers, and myself included. So so that's tough. You don't have a lot of resources. You've got demands from everywhere, and this pressure on you to kind of deliver in all kinds of areas, and really not a lot of capability to do that. So yeah, I mean, we were as new things popped up, we really want to do. We really want to do ad serving. It's like, well, we can barely handle what's going on right now. It was tough. So yeah, we were trying to support dashboards, materialize data for analysis, ad targeting, tracking, forecasting. How much inventory can we sell? Personalization, right? I mean, what conversations are interesting in your neighborhood, and what are just 2 really loud people talking back and forth, yelling at each other. That happens a lot in neighborhoods. And then, of course, we wanted to have cumulative stats, so things that matter. How many posts were there? What total lifetime, the lifetime views of a member, that kind of thing. We knew we kind of had to shift things around. And so we came up with kind of a high-level vision of what we wanted to build. So we knew that it had to be really simple to just be able to move and process data from point A to point B, but with a lot of flexibility. So this idea that, hey, we'd like to move everything into a data lake. We'd like to use Redis. We'd like to use Kinesis. We'd like to use Hive and Spark and all these other things. But we were in the world of, Redshift was the source of truth. It was the data warehouse. It was where people would do all kinds of data processing for the product. It was all done there. So we basically broke this up into pieces. It's kind of, if you think about it, it's really your traditional ETL, and you've got your extract transform side, and you've got your load side. And we just used S3 as a generic dumb transfer area. So what else did we need? Well, we knew we needed scheduling. We knew we needed visibility, monitoring. Really important was this idea that, we didn't want to be stuck with a few key, or like a small number of inputs and outputs. And we knew it needed to be self-service because as a 3-person team, we were not going to be able to keep up with the growth. And we have been trying to hire, believe me. We've actually, we cycled through one of those 3 people in the 2 years I've been there. And then ready soon. I mean, this was huge. We couldn't go off and build something for a year. We needed something now that we were drowning. So we did a bunch of research. Apache Airflow, it wasn't Apache at the time. It was just Airflow. Really ticked a lot of these requirements boxes. So we did our own deployment of Airflow. We actually did it through ECS, where we deploy a bunch of containers that run our Airflow cluster. And we knew we needed, to kind of get as much out of the box as we could, and then be iterative about how we went about building this. So some cool things about Airflow. Airflow gave us the ability to do interval scheduling. I want it once a day. Also cron scheduling. So a lot of things are coming over from a cron world. Really cool dependency management. I don't want this to run until that runs. And you've got all the downstream impacts handled. So if you wind up rerunning, step A at the left there, it will actually rerun everything downstream from there for you. Really nice duration tracking over time. So if I've been running something for a week, I can actually go and look back and see, how it's been trending, if there was like one big issue or that kind of thing. And then there's Gantt charts. There's historical. It's easy to find the logs and the logs of what happened last time. There's alerting. Anyway, they have a really good architecture for adding in inputs and outputs. So it's really easy to use. It's all written in Python. And it's really easy to extend. In some ways, too easy to extend, because people can wind up writing things that kind of just expand it in the same way that it was already handled somewhere else that you just didn't realize. So we addressed the self-service and the ready soon pieces with some Python code. And we wanted it to be dead simple. Again, I felt like, the simpler we could get it, the easier it would be to get other people doing the work. So, this is a dumb example, but you get the point. Take some SQL, you drop it into a file, you put the file in a folder that says, how often am I running? And literally that was V1 of this, and it was ready in days. That's what we had. You don't really need a lot of knowledge, and really you just need to know GitHub. And so then, again, what we're doing is we're basically generating an Airflow DAG for people, and you're pulling things from Redshift, you're putting it in the transfer area, and then you're loading it into someplace as well. And the name of the file was the name of the table and the name of the data set, so there's these conventions. And it was just, the transfer areas just contains plain text. So this worked. It was really, really successful, very quick. It was ready soon. And we had 3 people in the company, dozens of jobs within a month. They were doing it. We weren't doing it. And so all of a sudden, we bought ourselves some time. That was okay, cool, people are getting things done. Now we can make this a little bit better. So this is where we really started investing. At Nextdoor, we have this methodology of like move fast, but then invest. So don't do it all up front, but like get some traction and then invest. So this was kind of our investment phase. We moved the source of truth to S3. We built out a data lake. I won't go into that here, but that was quite the project. And then we used Qubole to centralize all of the metadata, to launch all our clusters, and run all our offline jobs. What else? Yeah, we love the fact that we can, hit the APIs and kind of spin up clusters and get results and all that. And so this unlocked tons of use cases because now we've got Hive and Presto and Spark like just easy, and they all integrate right into the same Airflow infrastructure where people can write their own. Now they don't just write their own SQL, they write their own Hive, they write their own, write their own Presto, write their own Spark. And you can output that data back to the data lake. So you can read from the data lake, you can crunch data in some way, and then you can write the output back. So we use Hive for data ingestion, materialized views, aggregations, and also we do format conversions actually through the same thing. It's just like, where do you want it to go? Oh, I want it to go to data lake, but data lake ORC. And it'll then do a transformation for you as well. We generally use Presto for like operational metrics, cumulative stats, basically like less complicated queries that don't require big joins. And also JSON manipulation, it's really fast for that. And then we're using Spark for inventory forecasting, sentiment analysis, feed ranking, personalization, that kind of stuff. So we also added some destinations, right? So now we're kind of adding these things on the edges where the core thing is still being used. And we added Redis as a destination, right? So now you can do a data pipeline that loads the results into Redis that the app is using directly. Datadog was huge. We're like loading operational metrics in there that aren't just, oh, someone viewed a page, but it's like something more, you're crunching some data to get that metric, and then you're using Datadog to watch that over time. So I guess I talked about that a little bit, but so we've actually got this as a part of, I don't know if you guys are familiar with the Lambda architecture, not to be confused with AWS Lambda, but you've got a batch layer and a speed layer. So we actually use this for the batch layer. We're doing, cumulative aggregates over time. There's a speed layer that's writing directly into Redis, same Redis cluster. We're storing our forecasts in there to be used by the ad server when serving ads and when selling, all kinds of things. With Datadog, we've got all operational metrics, as I mentioned. So I talked through that already. So what did we need to do? I really liked the simple file format, but we really needed to switch that file format because there was not enough metadata with a folder name and a file name. So we switched over to YAML so we could describe more things. And here we were able to, who owns this job? Who should be alerted if it fails? Who should they be, should it be PagerDuty? Should it be Slack? So the job author actually describes that. Dependencies, this was a game changer. First do this, then do that, right? And only run, wait for the data to be available, wait for this job to have run, all those dependencies, you just have a little text that's like, depends on. What do you depend on? Do you depend on a task? Do you depend on data? And then documentation. What data set are you producing, right? What are the column names? What are the data types? What's a description? And then we use that to auto-generate a whole data dictionary that is searchable and you can track it back to like who created it, and this is available all across the organization. And then there were some cases where we needed kind of pre and post hooks. Okay, I'm going to do this data crunching. But first I need to do some pre thing where it just executes some code before, executes some code after in the post hook. And so, here we are with this. It never feels quite done, but it's pretty mature. We've got, quite a lot of people. Our engineering team is probably over 60 people, and we've got, I think, 55 committers. So a lot of people are using this. It has really unlocked tons of use cases for us. And we've even got, contribution. So we made it so easy to create the inputs and the outputs that engineers are coming in and saying, well, for my project, I needed to get some data from FTP. So we're not doing that. Oh, sorry. They are, right? SurveyMonkey. We were doing some NPS results, right? Again, my team's too small to be able to handle that. We enabled other teams to do a SurveyMonkey integration, Salesforce integration, that kind of thing. Web crawler, API. An engineer added, wanted some secure configuration. They made a KMS interface for getting and decrypting keys from KMS. And so that took me a long time to build. I forgot to click forward. A lot of happy engineers. So I was brave enough to actually really get a picture of our GitHub. And if you look at the last month, I did this yesterday. This is real. We merged 73 pull requests, 22 authors, and again, this is just in the last month. So it's very, very active. And this is one example of a DAG, but we've got tons of DAGs. And you can see what people are not even thinking that they're building. They just say, I need this and that. And we generate this DAG for them. All right? So we wind up with all these DAGs that thankfully Airflow has a feature where you can kind of filter for just the things you care about. And so this view becomes like just the things you care about. So yeah, we run 50,000 tasks a day on Airflow. And so we're now handling dashboards, materialized data for analysis, ad targeting, tracking, and forecasting, personalization, and cumulative stats. We even added new use cases that we hadn't thought of with application level metric monitoring through Datadog. And we did this Lambda architecture that was kind of a pipe dream 2 years ago that we're now using in production. And we've done various other things that I won't even go into. So with that, I'll open it up to questions.
When you enabled your internal customers to pull external data sources down, was that data accessible at that point to the entire company, or just what they pulled down themselves in their own account?
So so it is accessible to other people, and so yeah, we don't have a kind of or I guess separate data isolation. We do. We have different Qubole accounts, and so there are groups of people that only see kind of what we make available in one account. So there is kind of a bit of a layer of, I guess, a visibility layer. One thing I didn't mention actually was we also, as people can do their own jobs, cost became an issue. And so what we do now in our review process is we actually ask that they do a run first, and we look at that run and tell them, okay, this is going to cost this much money. And so we've now kind of gone to that level where, because someone came in with a $50,000 a year job, that we're like, okay, that's cool, but do you really need this? And they were like, oh yeah, I really need this. And then we went off and built a little calculator and came back and said, okay, now punch your numbers into here. Do you still need that? Oh, no, I don't need that. So it's a good feedback loop.
Who's reviewing all the scripts and, I don't know, like the small piece of the software that people implementing, let's say I'm saying, okay, this is my script that's going to extract some data from somewhere and put it into my schema in my database. But being, like a major user or like not very experienced, I can break something. So I guess reviewing or like doing something to protect the data somewhere, because ELT or ETL, you can run some transformation somewhere where data is actually can be broken.
Yep. Yeah. So I mean, yeah, there's certainly, we're a small company, so we're willing to tolerate some amount of risk. There is some risk, but we do a review, and we'll include in that review people that are consuming that data. So in other words, if you're changing part A, then anyone who depends on part A is in the review of a change to A. So the question was, do we automatically scan for things in the job? And the answer is we manually scan it. It's like 10 new things a week or so. 70 some in a month. So it's a busy. So now we spend probably too much time doing review, and there are a bunch of things we want to build to kind of make this even further distributed. But I think the number of use cases that we were able to handle over the past year is like, we're really excited that we've been able to hit that. So yes, there are definitely, we want to make it better. That's one area where we want to be better at, kind of automating some of the review process.
Okay, yeah. You talked about 3 people in your team supporting close to 50 engineers, right?
Yeah.
How does the tuning process work, especially when your costs are going down?
Yep.
Is that something they do on their own? You enable them with something, or is it like you sit with them and do it kind of in a manual process?
Yeah, so I think the cost element actually was the key there. So anything that is not costing us that much, we don't even think about tuning. So once that cost goes above, so in other words, if it's going to run in time, it doesn't really matter to me if it's the most efficient, because making it more efficient might save us $300. I've got better things to do with my time, right? So if it's like $5,000, $10,000, like okay, now I'm interested. So yes, we review some things, and we do some optimizations for sure, but it really, we use that cost as kind of this threshold to help us filter. Yeah. It's not as exciting. None of this stuff is as exciting as you want it to be. Like sure. I'll show you my cost calculator after. The cost calculator it's a great tool. It's not like it's a lot of these things. I was in the Twitter talk, and they were talking about how they auto optimize MapReduce jobs, and I'm like, and as soon as they show the formula, you're like, well, yeah, duh. Those are the things that matter. Then you do the math, and you're like, well, okay, yeah. So it's like that, well, what costs money? Okay, put those things into the calculator. So yeah, we look at cumulative time, right? How much cumulative time did we use? And
do you think about data quality, data consistency checks?
Yeah, I totally neglected to talk about that. And actually, some of our data quality checks are actually, we do have data quality checks. We built our own little framework there. A lot of our data quality checks are actually involved in the data lake project that I described. And in this world that I'm describing, it's up to whoever is doing the job. If they want a data quality check, they do hey, depends on A, and then they're going to do some quality check on A. And basically fail if the check doesn't pass.
Any words on the CI/CD, like how you deploy that big DAG onto production?
I didn't talk about that at all. So yeah, what we do for deployment is from the time that we say, yep, this looks good, merge, we have Circle CI that does a build, and it packages up all the DAGs and all of because we've got these like ephemeral containers, right? And so they're actually checking S3 to see if any new DAGs were published. And so then they pull the new DAGs from S3. So within It's basically like 2 minutes from the time that you commit, you've got your new thing in prod. And the nice thing about Airflow also is the old jobs will finish as the new code comes in, right? So the new code is there. The next time it runs, it'll run the new code, but it'll actually finish up the current one that's in process. So, yeah. And really, it's nothing exciting that we're doing with CI, but it works really well. You know, you commit, it's out there. You commit, it's out there. And we do a staging process where people can, actually push their stuff to a staging environment and run it and ahead of time. Even that happens even before the review. Do we write that staging to a different location? Yeah. So we have templated. So Airflow has templates. I probably didn't mention that either, but everything is templated, and so you've got templated schemas, right? So the schema in staging is all these staging schemas, and it automatically, when you're running in production, the same exact code writes the prod schemas. Yeah, and then we use, schemas, or sorry, the templates are used for a lot of things. You have kind of a macro capability. You can write little. You can write your own little macros, Airflow macros, very easily, and do little, date math and that kind of thing.
Are you currently, just a quick follow-up question. Are you currently doing some kind of review, not the code, but the data pipelines themselves, just to check they are not redundant, and you are not moving and transferring the same data twice? If you can, merge two data data sets that has currently, basically was demanded by different people, but they're basically the same. Or maybe you have some ideas how to implement it in the future if you don't do this right now.
So if I understand the question, you're trying to kind of optimize around not doing the same thing twice.
Yeah, because it looks like you expose that to whatever in your company, just, hey guys, use it as your self-service ETL tool.
Yep.
And in such environment, you definitely will have the redundant data streams.
Yep. Yeah, so I think, redundant data, there's some of that. There's also, I think, given our size, given my team's size, we really have to strike a good balance of where is our time best spent, right? Is it best spent eliminating all the duplication? There could be some duplication. We might catch it in review. We might not, right? So again, the review is a manual process. So we're not that meticulous about getting it all just right. If it's kind of close, we get it there and we move on, because we're able to do so much more. We can focus on ad inventory forecasting instead of is the data there twice, right? And so if we had a lot of people, maybe that would be a big important thing. But and we did certainly focus a lot on cost savings and not keeping lots of copies of data around and stuff like that. But I feel like we're forced to kind of prioritize it. We're picking off the main bad things, but not everything.
So on data quality, you were talking about running checks on dependent data upstream before you set up your pipelines. At a higher level, what do you think is the right model? Is it a mix of people who are creating the data or publishers who should create these checks? Should consumers create these checks? Or do you see that the truth is somewhere in between?
The checks to see if the data's ready?
The health of the data, the quality of the data.
Oh, I see. So so we check. So there's a bunch of kind of primary data streams, right? We've got data coming from our production databases. We have data coming from our events. We've got a pub sub system. So kind of getting that source of truth, we do data quality checks, right? So the kind of the facts we check. But beyond that, if someone's doing something with that data, that's their responsibility to validate and ensure that it's correct. So that's what we do. I don't know if it's the right thing. Yeah, so do you mean having, okay, so the approach to testing in the architecture.
Yeah.
So I think there's two sides of this. One is, people throughout the company testing their work before they deploy it. And so for that, we have them, we actually created some scripts that, and CI, where they can auto-deploy to the staging environment. So like they'll push a new branch, and they'll push some code, and then they can check it, again, within 2 minutes of, hey, what does this do? Is it working? Is my upstream data ready? Let me rerun it, that kind of thing. And then we also write some code that's a little more frameworky. And so we have local development environment where we've got the same containers. All this is running in ECS. So we've got our containers on our just local Docker, right? And so we spin up the whole environment locally, and then we'll test code changes there. Well, thanks, guys. Good job making it to the very bitter end.